All right, so multiplying fractions, here we go. Okay, Davio ate 1/4 of a pizza. Ethan ate 1/3 of the remaining pizza. What is the fraction of the pizza that Ethan ate? Okay. Well, pizza sounds really good right now, but okay. So here is a little hot tip for you guys. The word of in math means multiply. Have you guys heard that before? Good. Okay, that's awesome. I'm so glad you've heard of that. Of means multiply. So when we look at this problem, if Davio ate 1/4 of the pizza, you guys, eyes up here, please. And Ethan ate 1/3 of the remaining. What portion of, let's take the portion of the pizza that was left after Davio ate 1/4 of it. How much of the pizza is left after Davio eats some of it? Ashlyn? Okay, 3/4. And how much did Ethan eat? Michael? He ate 1/3. Davio, yeah, Davio ate 1/4. Ethan ate 1/3 of the remaining. Now, if you guys notice, if we just, uh-oh, I don't know what I just did. It's not cool. This is not cool. So here we've got the remaining quarters of pizza. And you can just see from our bar model, how many units do I have left there? Owen? Well, okay, I need you to not move to a different question right now. No, we've got how many here? 3. Okay, we've got 3 units left. Ethan eats 1/3 of the remaining. So how much of the total, how much of the original pizza did Ethan eat without doing any math? Just look at the picture. Mira? He ate 1/4, but let's do the math now. Okay. When I multiply fractions, quick little reminder for you guys, I'm multiplying numerators and I'm multiplying denominators. Do you guys remember that? Okay, so I'm going to end up with 3/12. I know there's an easier way to do this. What, Piper? Yep, Davio ate 1/4. And so right here, there is 3/4 of a pizza left, right? Then it says Ethan ate 1/3 of the remaining. So we were determining what the of the remaining meant to start. Okay, Owen? You could also do 1/3 of 3/4. Multiplication is in any order. That's just the way that I started to explain it. So I wrote the 3/4 first. All right, what does 3/12 equal if it's simplified, guys? Rajveer? 1/4. Okay, there's a better way to do this. Okay, let's cross cancel. Let's do this problem again. 3/4 times 1/3. When you cross cancel, you have to choose one numerator and one denominator. All right, they can be in the same fraction or they can be in different fractions, but you can't do one without the other. If a numerator and a denominator have a common factor, you can reduce by that factor. So right here, I've got a 3 up here in this numerator, and I've got a 3 down here in that denominator, right? Are both of those 3's divisible by the same thing? Yeah, what's the greatest common factor that they'd be divisible by? Kylie? Yep. So that becomes a 1, that becomes a 1. Now I multiply and I get 1/4. Wait a second. Is that what you said? No, I said. Oh, it's so simple. Yeah, it is so simple. Just what you can't do is get confused about what you can cross cancel, because you can't cross cancel two numerators and you can't cross cancel 2 denominators. But we're going to get more practice. This is just my very first little introduction to that. McKinley? Yeah. Well, there wouldn't have been any point to that, because only the greatest common factor would be 1. Yeah. Okay. Since Davio, okay, I think we've gone through this already. Since Davio ate 1/4, how many parts remain and what is the remaining fraction? We already talked through that. Okay. Next one. 2/3 of the students in a class went to the museum. 1/2 of the remaining students went to the zoo. The rest of them remained in the school. What fraction of the students remained in the school? This time we're going to bar model this. All right. So you guys have an empty slide below to keep your work clean. So that's where you can go ahead and copy what you're going to see up here. Okay, just give me one sec. That's even more frustrating, I think. All right, maybe there's something wrong with my phone. I hope not. Okay, let's get back on track. All right, we're gonna draw a bar model to start. Here we go. And then let's just pick apart this word problem. It says 2/3 of the class of the students in the class went to the museum. How many parts should I divide this bar model up into to start? Kylie. Yeah, let's go ahead and divide it up into thirds. And let's mark 2 of the thirds as the students who went to the museum. 1/2 of the remaining students went to the zoo. All right, how many units do I have left on this bar? Ashlyn. I just have 1. So can I split 1 up into 1/2? Well, I can, but I have to manipulate it, don't I? Right? Okay. Yeah, I can split it into 1/2. But if I'm going to split that 1 unit up into 1/2, remember, I can't just split 1 unit on my bar model up into in any way. If I subdivide 1 unit, I'm going to subdivide the whole bar model. So what I've just done is I've subdivided the thirds, and now what's my denominator that I have on this? What would that be? Let's just say it, guys. 6. Good. Can I assign 1/2 of the remaining now to the zoo? Yeah, I'm going to give them just that 1 unit right there and call it good. Okay, so we want to know this. What fraction of the students remained in the school? Now you guys can tell me that just by looking at the bar model, right? What's the fraction? What is it, Dorothy? 1/6 remained in school. All right. Sometimes bar modeling is awesome. Sometimes you can do some things with math though too, or just with algorithms. So let's do this just using fractions. So now that we've seen the problem and we've seen it worked out, let's write an equation that we can solve. All right. So if 2/3 of the students in a class went to the museum, how many thirds are left? What's the remaining? McKinley. So we're going to start completely at the top again. I need your eyes up here, bud. Thank you. Not you, McKinley. Oh, you're getting ahead of me. Okay. No, it's not 2/3 times 1/2. Okay. Let's take out the kids who went to the museum. They're gone. They left for the day. What portion of the class do we have left? If 2/3 of the class left, I don't have left. If 2/3, don't deal with the remaining students yet. Let's just figure out what the remaining students are. If 2/3 left, how many thirds do I have left? Okay, so I have 1/3 left. 1/3 of the students in the class are left. Then it says that 1/2 of the remaining students, so there are my remaining students right here. Remember, of means multiply, right? So 1/2 of the remaining students went to the zoo. So all I'm doing is multiplying 1/2 times 1/3, and I get 1/6. That would have been a lot faster, right? We can do it that way. That's okay to do. But you should draw the bar models if you're not clear on exactly what the word problem is asking. Let's keep going. Well, it looks like you have a reprint in there. Do you have an extra print of that slide in your notes?
Yeah, but one of them is.
Oh, no, that's a new problem. I guess we fixed it. And that we had some notes where we had that problem reprinted. Okay. Amanda's house is 3¾ miles from her school. She walked 1/3 of the distance. Find the distance that she walked. Okay, we're going to learn 2 different ways to solve multiplication problems. One is going to be using distributive. and 1 is going to be using mixed numbers, okay? So method 1, I want you to write down, use distributive properties to solve the problem. You guys remember distributive property? Go ahead and write in your notes what you see up there in the red text.
Oh.
Yeah, distributive property means we're gonna split up a number and multiply the number that's split by whatever the multiplier is. So in this particular problem, if she's 3 3/4 miles from her school, one way we could solve this multiplication problem would be to multiply 1/3 times 3 and 1/3 times 3/4, and then we're gonna add them. So 1/3 times 3, that's pretty easy. We can cross cancel that. What's the answer on that one? Cameron? Good. We can cross cancel down here too. 1/3 times 3/4. We'll divide both of those 3's by 3 and we'll get 1. And what's the answer there? 1/3 of 3/4. You probably visualize that. Piper? 1/4. Now we want to add those. And when we add those, 1 plus 1/4, we're going to get the distance that she walked as 1 1/4 mile. So if we're demonstrating distributive property, this over here is really important to write down. So make sure you guys have everything on the slide. All right, ready to go on? Yeah, Uzziah.
You can kind of do this one in your head.
You could have kind of done that in your head, but I always want you to write down what's in your head. Okay. All right. The next method is to solve mathematically. So here's how we're going to do that. If we're going to multiply 3 3/4 times 1/3, we're going to change the 3 3/4 to a mixed number. So remember, to do that, we multiply the denominator times the whole number, and we add what's in the numerator. So 4 times 3 would be 12, plus 3 would be 15. So we have 15/4 times 1/3. Then we can cross cancel. Which two numbers can I cross cancel and what can I divide them both by? Mendel?
You can divide 15 equals by.
Yeah, nice job. So now I've got 5 times 1. Remember, we're multiplying numerator and we're multiplying denominator. 5 times 1 is 5. Put that up there. And 4 times 1 is 4. And now we need to simplify. We've got an improper fraction there, so we need to turn that back into a mixed number. So which method do you like better? Mathematically, or just solving mathematically, or do you like solving with distributive property? Tommy? Yeah. Mira?
I have a question.
Sure. Okay. Okay, so how did I get 5/4? Are we looking at this step right here? So I changed 3 3/4 into an improper fraction right here. Let me erase that 5 so I can walk you through it. And so I got 15/4, and then I asked, can I cross cancel 2 of those numbers? And so what we did was we cross canceled the 3 and the 15, and we divided both of those numbers by 3. So now I have 5/4 times 1. Okay. You know, I generally prefer solving mathematically, but there are problems that you guys will run across where solving with distributive property is going to make it easier. All right, let's go on. We're going to do both methods this time. Jim's bag weighs 4 4/4 kilograms. Madison's bag weighs 1/4 that of Jim's. What is the weight of Madison's bag? All right, method 1, remember, is distributive property. Can somebody help me set this up? Shafiq?
You do 1/4 times 4.
Okay.
And you
Wait, hold on. Before we even start solving, let's finish let's finish setting it up. So I've got 4 times 1/4. What else do I need to multiply by 1/4? Yes, great job. 4/5 times 1/4. Now you were about to tell me how to cross cancel on that, on this first one. What would you do there, Shafi?
Out to cross cancel 4/4.
Yes, great job. And then you just get 1. How about down here? Can I cross cancel on this next problem?
Yes. 4.
Okay, great job.
This is 1/5.
1/5, great.
And the answer is 1/5.
The answer is 1 1/5. And what's my label that I should stick on there?
Bag.
No, it's not bag. Here's my weight unit right here.
Kilograms.
Kilograms, good. Method 2 is mathematically. So we've got 4 4/5. Yeah, who can help me set this up? Times 1/4. How do I set this up mathematically? Owen? What's that 1/4 times? It's not, did you say 1 4/5? Yeah, it's 4 4/5 times 1/4. Yes. Now we have to change that mixed number to an improper fraction because we can't do the multiplication algorithm with a mixed number. 24/5 times 1/4. Great job. And then Owen, can you help me cross cancel? Can become what?
5. Wait. 6.
Okay. What am I dividing by? 4? Okay, so you're doing this one, and then 4 becomes good. So now I have 6 times 1. And then 5 times 1, I get 6/5, and we're going to change that back into a mixed number. And we get the same thing. Piper?
I'm confused on how you get 24/5.
Okay, so here's how I got 24/5. So my procedure for changing a mixed number into, let me do it over here, into an improper fraction. Maybe you'll remember this. Remember what we do is we take the denominator and we multiply times the whole number. Okay, so that gets multiplied. Then we add the numerator to whatever we got right there. Do you remember this now? Okay, so let me just break it down a little bit more. 4 4/5, if I were to, let's multiply 5 times 4. How many do you get? 25 plus 4/5. Okay, so you would agree 25 is 4 and 4/5 is left over. So to do that just more quickly, we just remember that we're multiplying that denominator times 4, adding the numerator, and then we're good. Okay. All right, let's go on. Okay, there are 3.5 pies left over from a party. This is a good day. Allie takes 3/4 of them home. How many pies does Allie take? I wonder how many people were at the party, and Allie took like 3/4 of them home. It seems a little bit unfair, but all right, let's go ahead and set this up. Your choice. Use distributive property or mathematical. Just do it mathematically. Okay. Ashton, do you have a question? Let's solve this together. All right, who's ready to help me? And tell me how to set it up. Mendel, go ahead.
I did this one last time.
You did this. Okay, so I'm going to start with 3.5. And we're going to multiply it times 3/4. And tell me what to do next.
And then 2 times 3
Mm-hmm.
equals 6 plus 1 equals 7 over 2.
Okay. Times 3/4. Okay, great job.
That equals E1 over 8.
Okay.
And then
We're really well done. Nice job. 2 5/8 pies. Okay, did anybody use distributive property on that one? Did you? Did you get 2 5/8? Great job. Nice. Okay. All right. So in your textbook on page 61, you have some Toyos. I just would like you to do numbers 4 and 5, please. Okay, now tell me what to write.
Emma bought 1 pound of spices. Cody bought 1/2 the amount of spices that Emma bought. How many ounces of spices did Cody buy?
Okay, what do I write?
2 1/4. Then I got 9/4 whenever I,
Okay, so you did 2 1/4 times 1/2.
yeah,
Okay, and then you went ahead and changed 2 1/4 to an improper fraction. You
Yeah.
got 9/4
Then I-
times 1/2.
yeah, and then I got 9/8.
9/8.
And then that's 1 1/8.
1 1/8. What?
Spices.
No, it's not spices. Ounces. Great job. Well done. How many of us got 1 1/8 ounces? Woohoo! All right, let's do the next one. Who's got this one for me? All right, Kylie, help me out. Can you read it out loud, please?
The longest side of a triangle is 2 3/4 times as long as the shortest side. The shortest side is 2/3 inches. Find the length of the longest side.
All right, what do I do?
I did 2 3/4 times 2/3.
Okay,
I made the next number 11/4
okay,
times 2/3.
okay,
And then 2 and 4 can be divided by 2.
okay,
So I got 1 and 2. So
okay.
that's 11/6.
11/6. Nice. Then what?
Which is 1 and 5/6
Nice job. 1 5/6
inches.
inches. Well done. Thank you. Ashlyn, you got something different? What did you get? I think this is correct. So let's just check it though really quick. 4 times 2 is 8 plus 3 is 11. So we have 11/4 times 2/3. So, and then yes, the 2 and the 4 are both divisible by 2. So I cross canceled the 2 and made that a 1, and I cross canceled the 4 and made that a 2. Then I multiply the numerator times the numerator, and that's 11, and the denominator times the denominator, and that's 6. So 1 5/6 is correct because we should have 11/6, and then we make that into a mixed number. Oh, but you're looking at this one. Oh, you did get 1 and 1. Okay. Sorry guys. It's just when I need to lock it. It doesn't, yeah. So this is. This is why you copied the wrong fraction. This should be 2 3/4. Oh, whoops. Okay, 2 3/4 times 2/3. Yeah, so you didn't change this into a improper fraction. That's why you didn't get the right answer. Okay, let's go ahead and take a look at the exit ticket problems. Okay, for letter A, you guys had 1/5 times 10 and 5/7. Did anybody get an answer for that yet? Okay, Cameron.
I got 1 and 1/7.
You got 1 and 1/7. Why don't I have this written down in my thing? Let's actually get 1 and 1/7. Let's break it down. How'd you do it, mathematically or distributive property? Okay, so 1/5 times 75/7. Is that what you had? Okay, so we can go ahead and cross cancel the 5 and the 75. When we divide 75 by 5, what do we get? Oh, okay. Oh, okay. I think 75 divided by 5, correct me if I'm class wrong. I think it would be 15, right?
Yeah.
15.
Yeah.
So we should get 15/7, which would equal 2 and 1/7. Then we had 2/3 times 6 and 4/5. Michael, help me out.
So you could just divide 2/3 by 6, which would be 4.
Wait, what?
Right. Sorry, multiply.
Oh, okay. So you're doing distributive property basically. So if you're gonna multiply 2/3 times 6, then you're doing it like this, which is just fine. And then you're gonna add 2/3 times 4/5.
Yeah, and I got.
Great, I love it. So that's 2/3 times 6/1. Whoops, yeah, I did. I wrote the wrong thing, didn't I? And you got 4.
4 and 8.
Okay, 4 and 8/15. I don't need the plus sign there because that's already a fixed number. Okay, nice job. How about C? We had 5/6 times 11 and 7/8. Ooh, I feel like this one might be a nice one to do distributive on, but yeah. Jace, what'd you do?
I got, but I just, I did mathematically.
Okay,
11 times 8, which is 88, plus 7, which is 95. And I simplified it with 6 and 95.
oh, you did?
And I like 15 and something.
Hold on just a second. I don't think we can simplify 6 and 95. Oh, maybe we can divide it. Can we divide them by? Let's see, 9 plus 5 is 14, so that's not divisible by 3 or 6. Yeah. Okay, who's got the answer on this one? Okay, what'd you get, Rajveer? I've got 9 and 43/48. I guess we're gonna have to do the problem, aren't we? Okay, let's do this let's do some mental math. What's 5 times 100, class? 500, so 5 times 95, which should be 475, right? Because we'd have 5 groups of 5 and we would subtract that from 500. So 475 divided by 48, divided by 48. Okay. So 48 is almost 50. So I'm going to say 9. 48 probably goes in there 9 times. And if we multiply 9 times 48, let's multiply 10 times 48. What's 10 times 48, class? 480. But we really only wanted to multiply 9 times 48. So let's subtract 48 from 480. If we subtract 40 from 480, we get 440. If we subtract another 8, we'd get 432, right? Are you guys with me? Okay, so let's subtract that from 475 and let's see if we're, oh yeah, we got 43. Okay, there's our remainder. 43/48. All right, in your planner, please write workbook exercise 3.